So I'm going to follow this list here and continue to build what I'm trying to build. And before I do that, I'm going to speak a little bit about 3GS, the design, and the reason why I think that they did the design the way that they did. But I still think that the way that I'm doing is probably better, at least for what I'm trying to do, because I don't have as many features, but I imagine that there is ways around it as well. So it might be possible to make 3GS better, but it would take a massive amount of work, I think, to do it on JavaScript. So I don't think I'm going to spend time doing that, but I want to explain because I'm understanding more now how it works. So I'll put some music. So the reason why, the way that they did it is I explained some of the live streams that I did, but just an overview is they manage the programs through main classes that they create on the renderer here. So they create this geometry, the binding states, and the attributes, I think. Here. The texture also, but I didn't spend too much time thinking about texture. And also this material and these properties classes. So the way that they do it is that by creating these classes here, that they're gonna manage at the high level how to deal with the shaders, the programs. And the reason why I think that they do it like this is because they create the programs based on each material. So maybe we should go, because the thing is very confusing to explain. At this point I tried to explain a bunch of times, but it's still very confusing. And this is the reason why I think that's this other approach is probably better, even if it's a little bit less performant. But I think I can find ways around it. But pretty much the reason why I think that they do it like this is because they attach the creation of programs with the uniqueness of the material. So the thing that is visualized on the screen is a mesh, and the mesh is created from a geometry class and a material class, and the geometry handles the vertex attributes, which are the points and whatever information the points are going to have. And the fragment is the color and other attributes as well, but usually it's going to be the color. And so for example, you can imagine that you create one single program, and let's say you want to draw a bunch of spheres on the screen. So one way to do it is create a single program for each sphere, and then you send data to the buffer, the vertex buffer, and specify to OpenGL how OpenGL should consume that buffer in order to draw stuff. And then obviously you're going to have the fragment shader as well, so vertex and fragment shader for that specific sphere. Or the other way would be to create only one program, and then the program is going to render all the spheres simultaneously. So let's imagine you have 10 spheres. You create one program, and then you render all the 10 spheres. And the way you do that is pretty much the same way. The only difference is going to be in the way that you send the data to the shader, which is by creating the buffers and passing the data, which is going to be from the buffer geometry class, which is going to all the geometries are going to have that as a base class. So the buffer geometry is going to be the one that it specifies how what attributes is going to manage what attributes are set in the shader and the formats that the buffers are going to have to send, and this is going to happen on the binding states class. So if you do it like that, it becomes a lot more effective, because then you only have to use one program, and then you render everything at once by sending a bunch of data. And OpenGL calls are very expensive. So the other approach is you have to create a unique program for each thing, and then it becomes a lot slower, because then obviously you have to create a bunch of different programs and then set them. So that's the trade-off. Is like, in one way, if you create a unique program, you have less flexibility, but it becomes easier to. No, you have more flexibility, but it becomes easier to understand, but you lose on performance on some cases, because the issue with doing on the way that's on this way, where you create only one program to manage a bunch of things, is that their color is coupled with each other. So the moment you want to change one of the pieces of the visualization, you have to change all of them as well, even if you're not gonna change the position, because you have to, because they are connected through the same program. So you can only update them through the same program. So they're more coupled with each other, but it becomes faster. So, and this is another technique that I've learned now. I think I watched videos before, but it didn't make sense because I didn't have the context, but now I have, which is batch rendering. So there's a way that you can do it, which I'm thinking about doing. I'm not really sure if I'm gonna do it or not. I think I'm gonna probably try to do this later on. But pretty much the way that it works is that you can send data from the vertex shader to the fragment shader, and the way you do that is by specifying variables called variants. And if you do that, what it allows you to do is to structure the buffer in a certain way where you can not only send the data for the position attribute, for example, you can also send the data for the color. And the way that you do that is just by calling some OpenGL function, and then you're going to specify to OpenGL this stride, which is how much steps to the right of the array that you're sending as a data should you take in order to get the data that is going to be related to the color. So you can imagine that you're sending not only the data for the position, but the color as well on the same array. So you send all of them simultaneously. Then you declare a variable inside of the vertex shader, and then you use that variable inside of the fragment shader. And if you do that, then they call this batch rendering because you can draw multiple different points with different colors. And the difference is going to be on the way that you structure the data that you're sending. So it's kind of like you get the best of the both worlds, because you're rendering a bunch of things at the same time, but you're only using one program. So I think that doing this makes the thing significantly faster. And they have an option to do that, which is this use color alpha, which comes from the vertex alpha, which you can see on the rendering cycle that they do on 3JS. And if you specify the vertex alpha, which comes from it's gonna come obviously from the geometry class, because the geometry class is the one that is responsible for managing the data related to vertices. So if you put that, then there's gonna be some logic that sets on the parameters that this value is true, and then it puts this option on the shader, which makes this color here, which is a varying color that comes from the vertex shader. So, and then I haven't studied that much to understand. This is one of the things that I'm debating whether or not it's worth it, because the biggest problem with this is that you have to think about how you're going to structure the data on the buffer, which are the functions that you call from OpenGL to tell OpenGL how to read the data that you're sending to draw stuff. So this is a very annoying thing to do. It's kind of confusing, so I'm not really sure if I'm gonna spend the time to do that, but probably. But the reason why I was thinking about this is because, based on the way that I did, this becomes a problem, because if I want, but I thought about this before as well, and this is the thing that I'm not really sure, because the way that I'm doing things is that I'm separating everything into a unique program, so that's the main difference. So OpenGL creates these classes in the beginning on the rendering cycle, and they use these classes to specify, or maybe I should do this version 3JS with JavaScript. And then they use these classes to manage, and I think that the reason why they use these outside classes and they don't do it the way that I'm doing is because it allows you to have more flexibility, because of these things where you can have shared states between programs, and because they select which kind of program they're gonna create based on the material of the mesh and not the mesh itself. So you can have a situation, for example, where you initialize multiple different meshes and you use the same material for all of them. So it's the same object in memory, and which is something that I think I thought about for my use case, but the thing is I'm not gonna be able to do like that, because for my case, each sphere, I want to have the potential for each sphere to have its specific color. So one thing that I was thinking about is that maybe I can switch back and forth between the two approaches, and then depending on what kind of modes, you can offer the possibility to put a mode where all the colors of the nodes are going to be the same, or some of the colors of some nodes are going to be the same. So for example, if you want to cluster or do something like that, and then if that's the case, then you put a logic condition that does batch rendering for the colors that are the same. In this case, you use the same material. So, but here I'm using like a unique material for each mesh that I'm creating here through this function. And one thing that I could do is just pass this thing to the global variable here, and then I can create multiple different meshes using the same material. And based on the way that they designed this, because they are doing the programs based on the material of the mesh, then they will only create one program if that's the case. And in the way that I'm doing, I would create multiple different programs regardless, because I'm separating the logic in the program itself. So that's the main difference. That's the downside of the approach that I'm taking. But then the thing that I think about, but like this can be a problem for me in the future, I'm not really sure. But I'm betting that it's probably not, because what I thought about is that instead of doing that on the rendering cycle and using all these other classes to manage everything, I can just do them on the programs class. So the idea that I have is just pass all this functionality to manage all the shaders and the logic on the programs class. Because you still achieve the same result, but instead of having to create all these other classes, and I think that way it becomes a lot more confusing. This way you probably, but this is the thing that I'm not 100% sure, maybe I'm wrong. But I think it probably becomes easier because I can put logic here that selects different shaders, and then I can put some control variables, maybe on the rendering cycle or maybe on the material or geometry classes, that are gonna tell this class if it's necessary to bash rendering or something else. The other thing that you can do that uses like pretty much along the same logic is to create these uniform buffer objects, which is another buffer that OpenGL provides that allows you to set the uniform variables for multiple different programs at the same time. So I think that this is the main trade-off here. That's probably the reason, one of the biggest reasons I think why they designed 3GS the way that they did, just because of the flexibility. There's this relationship of how many programs you have and the things you want to render. I think that's the main point of the trade-offs between optimization and making it easier to understand. And it's probably because of the way things evolved as well. Because like it's harder to build when you don't have everything in mind. So it's easier to look back at it after it's done to see, like, because when you're building, you're just putting, so it's hard to know like how the thing's gonna evolve. So you can look back and then try to build from that place. So I think it's understandable, but it can probably be better, I think, if it's done the way that I'm trying to do here. So this is what I'm thinking about, and this is what I have now so far. I spent a bunch of time, and I'm still not really sure. It is working fine, so now like this is what I have. And I did something with the position to see if it's gonna move, and I figured out why it wasn't updating here. It's just because of the GL view part and a function from GLFW that updates the frame based on the window size. So you have to call GL viewport to determine what is going to be drawn. But this edge here took me a shit ton of time, and I'm not really sure. I think it's the edge that, yeah, the edge took a lot of time, and the other ones not so much. And it took a bunch of time because of polymorphism or like something with the templates, because this class here, they have a variable that is declared with curve tree, and I wanted to pass the line curve tree or this quadratic Bezier curve tree, which are two different types of curves, to initialize this class here. But because one of the variables is declared as curve tree and these other classes inherit from curve tree, then I was trying to initialize the tube geometry with a template instead of specifying curve tree as the variable. And then I got a shit ton of problems. Then I realized that it is actually not necessary because the compiler figures it out. Even if the variable is specified as a vector tree there, it works. So because it works, I don't think I'm gonna pay too much attention to this. But this is the thing that I'm thinking about now, because I was thinking about not even doing the uniforms here, setting the uniforms on the shader because of this optimization thing. Because now the way that, but then I decided otherwise, because the way that I'm setting up the programs class is gonna shape the way that the way that I'm setting up the program class is gonna shape the way that I'm going to have to set up the programs class in case I wanna do optimizations. Because the main thing between them is the gradient of buffers you use and how the quantity of a variety of programs you use as well. And that's going to be intrinsically correlated with the way the way you're shaping the visualization. So the variance of data is going to determine the connectivity of everything. The more connected things are, the more of incentive you have to use only one program, because then obviously you can render everything at once by sending a bunch of data. And the more variance things have, the less incentivized you are to put everything on one. So the more incentivized you are to create a variety of different programs and then do the way that I'm doing. Because then it becomes a lot easier, because all the logic of the program is separated on the programs, that makes easier to make sense of it. But then you lose the flexibility. So I assume that obviously the answer is going to be on the middle, so it's going to be a convergence towards the two. And that's where the complexity is going to arise. So as I build the program class, I have to think about like the structure of these functions, how they're going to affect the way that I'm incentivized to build this class later on, if I want to optimize, to add the possibility of rendering multiple things at the same time. So do batch rendering or add the different option. So the one that I'm thinking about the most is this one of the vertex, because I thought that one, because then like the main concern that I thought about from creating only one program is the colors, because I'm gonna have to keep the colors independent for what I'm trying to do. But if I do this technique of the batch rendering and sending the color to the vertex, then I can do multiple different colors and draw everything at once. So I think that's going to be far more effective. And that's making me think on the way that I should manage here. Because the way that I'm doing now is I create on this function here. So I create the class on the constructor. As the render is initialized, the programs class is going to be initialized here. Then on the first render, I call this function here, which is going to traverse the tree. The reason why it wasn't working last time that I streamed is because of this logic here. So it wasn't creating a unique ID, or the ID was messed up because of the way that I was increasing the ID. And for that reason, it was only drawing one thing on the screen. So I fixed that. So inside of this function that traverses the scene graph and gets every mesh on the scene graph and calls this function here past the mesh, then I'm creating the program here and I'm caching the program through this ID, which I'm not really sure if I should, like, I think it's possible to change this, but I'm not really sure if it's worth it to do this now. So as far as I understand, static means that, so when you have a class or a struct, class and struct is the same thing. The only difference is that struct, the variables are public by default, everything's public by default, and class, everything's private by default. But they work pretty much the same way. So the way that the structs or classes work is you create a template for initializing objects that are going to have those characteristics. So these variables and these functions. And when you use this static keyword, instead of creating one instance of the variable for each time you initialize a class, it creates only one instance for the class itself. So every instance of the class is going to have the same variable. And this is the reason why, and this inline just replaces the definition on the thing. So I'm not really sure if it's necessary, to be honest. And this I got from the other project, so I'm not really sure if it's necessary to do this way, because maybe I can declare the ID as inline static. Maybe I should try that now. And then it just initialize. So I think it has to be public though, if I do that. I think it's not that big of a deal, so I'm not gonna think about this. I'm gonna think about the other stuff. So this is the thing here, is that, so now I think I got to the conclusion where it's probably better to just do, as something that I have to do is just separate, because I put everything on the constructor here to make it easier to think about, but I'm probably gonna do this now. So separate this part here. So at the beginning of the program class, I received the shader paths from other functions that I got from ChatGPT, which get the relative path to these files here from the build folder, which is the final folder. Then it reads the file, gets the string for the source code that is on these files here of the shader, initialize the program. Then on here, the way you have to do it is you create a VAO, which is a vertex array object, which is going to be just a container. So I think a way to think about it is like, it's not going to be the same. I don't know if it's going to be the same or not, but just as an analogy to make it easier to think, is kind of like a heap space. So like you're allocating a space when you use the array and array object to save the state of whatever configuration you set here. So these functions here are going to determine how, so you're going to create the buffer. I think I create the buffer before. On this update here, this update function calls another function. This is the type of the buffer that I'm going to create, which is array buffer. And then this is the attribute that I'm getting from the geometry, which is from the mesh that I use to initialize this class here. So I'm passing the mesh on the renderer. And then here, it creates the buffer because I don't have, this is a cache that I'm going to cache the attributes with the information for the buffer so I can find the variables later. But you create the buffer, and the buffer is just a space on memory that is going to receive, you're going to pass the data that you want that place to hold, let's say, which is the data you're creating from the geometries for the positions. It's going to be an array of vectors. But I think I'm not 100% sure. I think it's just getting the data. So this is a vector, and it's a vector of vector trees because each place is a position. And then it just gets the data of that vector and passes here. Then the buffer type and the size of the memory that you need to pass. So it creates this buffer, and then after you create the buffer, you have to specify to OpenGL how it should read the data from the buffer. So when you're running the program, OpenGL is gonna take the data you put there, and it's gonna get all the data and replace the values of the variables inside of the vertex shader with that data that you're sending. And that's based on the location of the variable. So the location is the index here. And you get that with this function here. So you just pass the program, call some OpenGL functions, and then here I'm caching on an order map to cache all the information for that attribute, the location, the name, this stuff, with the name. So mapping the name of the attribute with the information that it has, because later on you need to get the allocation to update there with the other function, this function here. And the program attribute here is just the location. So then after you do that, you have to, if you're using an index attributes, which which is another optimization, most of these classes are gonna use indices attributes, which is just an array of data that it specifies whenever you have repeating positions. So you can imagine that each point is gonna have 3 coordinates, which is x, y, and z, and then depending on what kind of geometry you're drawing, a lot of the points are going to have the same coordinates because they're on the same plane, for example. So in order to not send all that data, you can shrink the size of data that you send by specifying what kind of indices the data is going to be repeated. And that's the index buffer. So if you have that on the geometry I'm doing here, you also create a buffer and then bind the buffer. And this one, I think you don't need to call this other function. You just create this buffer and bind it. And then depending on the way that you're gonna draw, you're gonna do the draw call, you're just gonna know that, so you're putting both of these things, this buffer here and this other one, inside of this VAO, which is vertex array object. It's just a place in memory, so you're putting them there. And then OpenGL is going to store the state of the structure of the recommendation of how you should get the data that you're feeding to it. So you don't have to specify this all the time. So just saving the state. Then after you do that, depending on the way you call the draw call, it's going to know how to use the buffers that are inside of the VAO to draw the stuff. So for the uniforms, I think, I'm not 100% sure, but I think that you should, no, this is the thing that I was gonna think about now, which is like on 3JS, they update based on a variable called refresh materials, I think, which is based on whether or not the material changed, but I think that this can be optimized, but I'm not really sure if it's worth it to do that as well. But the way that it works, I think, is like in the first rendering cycle, you just set all the material properties you want, which you're gonna do based on some confusing functions here that at the end of the day, they are just calling these functions, OpenGL functions, that are gonna use the data that they store by getting the uniforms. So this is the function on C++. Maybe I can find the way that they do it on 3JS, but they're just getting, just using these functions, which is similar to the way that they get the attributes location. You call some OpenGL functions and then you store them on a struct. And then based on that, you cache them on a map. And then you use that map later on to create a function that's going to work as a template. You send the name of the variable you want to change and the value, and then it's going to, based on that map, it's going to call whatever function from OpenGL should be used to update that variable. So there are multiple different functions that you can use, and each one is dependent on what kind of type it is inside of the shader. So I have this tree here, which is the ones that I'm using for now, because I did this for the float. And so the first time that you run, I think you should set all the variables that you have on the material class, which they're gonna do based on the material properties that they initialize at some point, and then they have some control flow to put the values, to create the shader based on the values of the material. It's gonna be on the parameters. Things on the programs, get parameters, this function here. So they receive the material, and then based on the material, they have these conditions here. And this object is gonna be the one that they use to update the material properties on the rendering cycle. They're just gonna have all this stuff here. And then based on this stuff, when it's creating the program, it's gonna do the logic to see what kind of stuff, what kind of logic you're gonna put inside of the shader, final shader code, which is based on this thing here. So the way that I think they do it is on the first cycle, they set everything that you have on the material based on these variables here. So they create the shader program, add all this stuff, and then based on whatever you have, they're gonna go on a loop, and then they're gonna set all the uniforms based on some functions and logic there that they put on the rendering cycle. And then the only time that they're gonna update after that is gonna be whenever you have. This is the part that I don't know very well, and I'm kind of confused by, but I think that's my intuition is correct, which is, so for example, let's say you create the mesh or the material with the color blue. Then the first time is gonna set as the color blue, but then let's say at some point in your application you change the color from blue to green. So if you change the color from blue to green, it's not gonna change if you don't have some logic. So you need to refresh the material inside of the rendering cycle. And the way they do that is based on a property, I think. So this is the stuff that I'm trying to figure out now, because I think that the logic has to be inside of the material class, because when you set the value, it changes the value of another variable that is going to indicate to the rendering cycle here that's the material changed. And then based on that value, they're going to have some control flow logic here that's, if the variable is changed, then you update the uniform. So, but I think that the thing that could be optimized is that they do it on a generic way. So they just have the flag variable, and then like they update all the uniforms regardless. So I'm not really sure if that's necessary or not. because you can have a function that based on whatever uniform was updated, then you. But it might be not worth it because it's just too complicated and it's like one micro optimization thing. So not really sure if it's worth it to do. So probably I'm gonna do it just a simple way that they do it here first, if I'm understanding what they do correctly, which might not be. So, but what I'm doing here. And that's the part that I'm working on now. I'm creating this function here. It might go. What I'm thinking about doing. So I'm running into a problem now, and I'm gonna have to think about this as well because I'm passing material here. Because I'm thinking about later on, I might have different kinds of materials instead of just mesh basic. And then I want to specify there's a mesh basic material. But the way that I did the classes, the way that I'm initializing them, the color property is gonna be on the mesh basic material class and not on the material. So when I do this, it complains that the material doesn't have a color, because it's supposed to come on the mesh-based material. So I have some problems on the initialization that I'm not really sure. I think I'm gonna have to think about this now. But so what I'm thinking about doing is just creating this function, and then instead of the rendering cycle, I just call this function on the first render. So based on this thing here. So set the projection matrix separately. Then I just pass the material and the mesh ID. And then based on the mesh ID, I access the program because of the way I'm caching here. And then I'm gonna have a bunch of different conditions here. So all the variables that I have on the material is gonna be these variables here. But honestly, I think I'm just gonna do colors now because I don't see the point of the other ones. I simplified the shader a lot, so I only have these things here. I also think I'm gonna remove this stuff here because I just wanna put the stuff that I'm going to use and that I learn as I go. So that I think might be useful. But the thing that I'm thinking about the most is definitely this optimization, which is the both using UBU, uniform buffer objects, and using the batch rendering technique. So setting the color on the vertex. And the thing is, if I'm gonna do that, then I'm gonna have to think about how I'm gonna set these uniforms now. Because I'm also gonna have to, so the idea that I have is just to create other functions here. But this is the thing that I'm not 100% sure. So I can create another function inside of the programs class that based on whatever, I can add some logic somewhere that determines what programs are gonna share a certain data. So based on that, I can determine how I cache the shaders. So this is something I have to think now. It's like, what is the best way to, and I'm not really sure if it's worth doing that now. That's the thing. So maybe it's just, I think I'm not gonna do that now, honestly. Maybe I'll think about this later. But I have to think about in the context, just to make sure that I don't get into a position that later on is going to be a lot harder to change everything because of the way that I'm setting things up now. But I think that the reason why I'm thinking about not doing this now is because I have too much stuff to do. So maybe once I have everything else figured out, then I think about this. But yeah, I think it should probably work. I don't see why. So I have a logic. You have a function that's based on. I can put the question is what is the best place to put the logic that is going to determine what kind of programs are unique. And I think this is the tricky part because it's going to depend on the way that you send the data. So the variance of the programs is directly correlated with the structure of the data you're sending. So I think the first thing that I have to do is just separate the functions on the program here. So I'm gonna separate this logic, and that's what I'm gonna do now. I'll be right back. So I think these ones that don't make sense because they're already in functions. So I think I'm just gonna leave it like this. But probably this. The question is how much I should. So let me think about the name of the function. So it's probably gonna be setup and setup vertex buffers, probably. The uniforms don't really have a buffer. So the way you update them is just by. So the buffers is just related to the vertex, I think. Unless you want to do one of these techniques where you send a bunch of data to do the colors at the same time. So I think probably setup buffers, setup vertex attributes. I'm probably gonna put here. Setup vertex buffers. And this is the problem, is because it's not that big of a deal. I can access by. Can just change the name. So here I'm accessing the one that I'm using to initialize, but I'm thinking about whether or not I need to pass anything as argument, but I don't think so. So when you're inside a function that is part of the class, you don't need to specify the class to access the variable. I believe that this is not. This is only not the case whenever the variable is static, because then the variable is not from the instance of the class, but from the class template itself. So if that's the case, then you should put the program thing, like here, for example. So let me think about this. So now I'm just gonna call. From there, I'm not gonna compile. So the two things that I wanna do first, probably just set the. And this thing about the batch rendering really, I really want to do that because I think that's gonna. It sounds like something that is gonna improve a lot, and shouldn't be that hard, that much work. But the biggest issue of that is, and that's kind of the reason why I'm kind of hesitant about this, is because I think in order to do that, I'm gonna have to go over the way that they set up all these functions here to get the points, and I really don't want to do that because it's gonna be a lot of work. So, like, the best way would be to do in the similar way that I did to translate everything. So, because they have the option, and this is the reason why I was studying now this thing, because so I was looking for vertex alphas, because I know that they, as I was studying this before, I know that they give some option to put colors on the vertex shader, and that's how I figure out what variable that they are setting there on the program. So they do it based on this, which defines this one on the shader, and then that's how I knew, because I search this one there. So the name of the the variable inside of the shader is going to be this one. The weird thing about this is that this one the way that I did this is just by copying and pasting all the code, so it's not directly from 3JS, so I might have missed something. But what's weird is that there's no undefined here, so I think I just missed this code when I was building this thing here. Here they are putting defined, but I'm not really sure. That's the difficult part, and because the thing that I was searching is how can you, what is the correct way to send the data to the, and I think I seen the best video from this was from Cherno. Yeah, this video here. On this video, he explains that you should, the way you do it is just by passing as the data. You pass in the same way that you do it on with the vertex, but this is the reason why, like, I'm not really sure if it's worth it to do this, because it's gonna be very, I hate this part from OpenGL, because it's very confusing and it seems kind of loose. But I think it has to be this way because of the way that things are set up, but it makes it really hard to think about, like, to visualize in your mind how the data is going to be at the end. Because you have to imagine all the pipeline from the geometry class until you build the buffers, and the moment, like at what points you're going to build the buffers, and then how you're going to cache the attributes and cache this data that is from the location of the variable inside of the shader that you want to set. And then you have to think about the stride. And then not only that, the thing that's going to make it a lot harder is the thing about the programs that I'm not sure, because you can imagine if you have several different programs, then you're going to have several different vertex shader code, and you're going to have several different ways you're going to pass the data. That's the problem, because then all these ways are going to change the way you should call this function here. And this is going to make it harder to know. So to think about what is the best way to set things up. I think one idea would be, for example, to create another program class, just pretty much copy everything that I did on the other program class, and then the only difference would be, like, I changed the name to batch program or something like that, and I would change the way that I do these functions here. And then I can put the logic on the programs class of whether or not the mesh is supposed to use batch rendering with other meshes or not. And if it is, then I use the other program class. If it isn't, I use the first one. But the question is that scalable or not? And what kind of problems I'm gonna run into if I do it this way? It's very hard to think about this. So maybe I should, because there's also the thing that there's so many things to do. So I don't really know. I think it's probably better to just build everything and just think about this way later on. After I have everything, but the concern that I have about that is that then if something breaks, it becomes harder to debug because you have so many other moving pieces. I think I'm just gonna follow this thing here that I have. So I'm gonna finish this other stuff, and then if I get to that point, when I get to that point, I think about what should I do. So maybe what I should do before anything is just set the color instead. So there's two main things that I have to think about now. One is how is going to be the structure of the function. I think I'm not going to do that now, like this function here. It's probably easier to just set the color so I can see if it's working or not. just set the color and the other variable that I'm gonna use on the shader, and then think about the function later on. Because this one I'm thinking about. So there's several different things as well. The way that they do it on 2JS is that they have a generic function that based on the material type is gonna call other functions. So this is one way. I can put switch statement here. But then it becomes really annoying because of C++. So I think it's just gonna be a lot harder if I do it this way. Because then I might have to use a template and it's gonna fuck everything up. So I think that probably this thing about the conditions. So just pass one material and then check whether or not the material has some properties. Because that's gonna be the main difference between materials, I think. And then if it has, then I update the value. But I think I'm gonna do this later, and I'm gonna just call these functions here probably. Just see if it's gonna set color or not. So I need to pass the name and not sure if I can do like this. So the geometry I have to call this function here to get because of the way that he designed the initialization. There's probably something similar with the material. Oh, it's just materials. Oh, it's a vector. It's another thing. So I'm just gonna do like this for now, probably. It's probably so I have to do share material or something like that because it's probably private there. Protected. Yeah. Mm. No, it's not this one. It's this one. I'm trying to think about how can I do this. I think there's just a shared geometry function, but there isn't. I guess I can just put like do the same. But the problem is that it's gonna be a vector. But I guess I can do that way for now. I maybe should just remove instead of creating the vector, just create a share pointer. Maybe that's better. I don't understand how this works as well. So like here is moving only once, only one thing, but is a vector, not a share pointer. So I don't know why it doesn't complain here. The question is, should I simplify this and just remove the vector? Because it goes back to the like the whole way I'm creating this stuff. Like the way that I'm thinking about it is just remove as much complexity as possible, and then only add complexity when I feel that's necessary for the thing that I'm trying to do. I think that's a better way to. So I should probably I'm just gonna remove this. The problem is that. So I'm gonna comment this out, then try to compile. Because if I remove, then it might break a bunch of things, and then I'm not gonna be sure what thing it is. So first I'm gonna see if it's working, and then if it is, I'm going to change there and see if it breaks anything. And then I'm just gonna add another function there as well. As on the mesh. This goes. I think it was here. Yeah. So if it doesn't break anything, I'm just gonna. Oh, it's because of the. So I'm not really sure if I should put some. Probably I should put some error message or something like that. Just because of this thing here, I think. Yeah. So maybe let me do this way first. Also, there is a function here to get the material. Hmm. It's just the same function, but with different things. So it's saying you can convert. Not really sure what this means. It has something to do with this, the material class. It seems to be that you can't convert the type of the shared pointer on the mesh with the type here. That doesn't make any sense to me. Because I'm not passing a vector on any of them, so... Oh, it's this one. The error message doesn't make sense to me. If it is this, maybe something else. This is exactly the same error that I was getting before on the other class when I was trying to fix this thing here. And this one, like, I still couldn't figure out what the error was because of the way that I fixed. But I assume that is something to do with the... because I was using a template class. So this might be very annoying to figure out. There was something related to abstract syntax class as well. I think it was complaining if I try to initialize this. So I made this class as a templated class, and then I tried to initialize as a just with the curve tree type. I think that's the thing that made me think that I should change the class or something like that. I don't remember really well, but it gave a warning that you can't initialize with abstract classes because the compiler doesn't know the size of the class because it's abstract. So I'm not sure if this is related to this thing here. Public virtual class, standard vector class. It's probably because of the definition somewhere. Yeah, this. Well, this is another thing that made it difficult to think about the other one, is that these classes here are static. And I think that they are static because of the memory, something to do with the way that he designed this to handle the memory. But I don't know. Hmm. It shouldn't be anything to do with these functions, I think. Or this class. Resolve the external symbol. Public virtual class. Mesh materials. Maybe it's one of the functions here. No. So it might be because of the type here. Or because of this function here. This is just creating a shared pointer. So let's see why. It could be because if you have the vector, it figures out because the type doesn't need to be like can be mesh basic material. Well, I think I've studied something like this because of the other error. So there's something called object slicing, and the way that it happens is that once you have if you have a vector or a queue or something like that with one type, and then you have which is a class, for example, and then you have another class that inherits from that class, and then you push that class into the vector or queue, something happens which is called object slicing, which means that some of the variables of the inherited class or the derived class are going to be lost because the compiler, I think, reduces the type of the class to the base class. So it still allows you to push the derived class to the thing, even though it's not the same time. And I think it might be like this is that is happening here. I'm not really sure. Because on the mesh, I think the type is material. So because now I don't have the option of the vector, it doesn't reduce the. Before it was reducing the mesh basic material when you don't have the defaults, and now you can't have that option because you have to specify the type. So maybe this is the reason why he created like this. So the question is, what should I do? Like, what's gonna be? Because I don't want to spend a bunch of time thinking about this. And there's other stuff to figure out. I think that one easy way to test would be to just do like, yeah, but the problem if I do this, I think it's gonna complain. Because the material class is an abstract type. I'm not really sure. Yeah, I think it's just gonna complain. And I can make it work by removing the constructor. I think the constructor is probably protected, but it's just gonna say that it's an abstract syntax class. So I can't do that. So let me see. I'm not really even sure if that's there. This is one of the most difficult parts of C++ so far, and it's because I don't have a lot of experience with the logging. Someone recommended to me this library here to log stuff, but my concern is that's gonna take a bunch of time to learn this, and I think I can get by just by doing doing print statements as checkpoints. But it is a lot more difficult because the errors are more generic, so it's hard to understand. or to know exactly where the thing is coming from. Okay. Oh, it's this one. I'm not sure if the object slicing thing makes sense. I know that this is how it works based on the videos that I watched. So I know it is a thing, but I don't know if that's what was happening here. On the other one, even if there wasn't an error, I think that it might be the case. But maybe not, because if that was the case, then it wouldn't solve the issue. Because it wouldn't. This is something that I'm trying to think about, and I haven't got an answer so far. I'm trying to clarify my mind. What are the best keywords and search terms for this? Maybe a compiler deduction or something like that. Like what made it really hard to think about this one is that you have several different principles involved, and it's kind of hard because it is a kind of like a black box, because it depends on the compiler you're using. So you have the concept of the class, and then the concept of the template on the class. That makes it harder to know, because one of the questions would be what exactly is the relationship between the templates and the class itself, the class instances, and how does the template deduction of the classes and template specialization and other stuff like that relates to static functions and other types inside of the class. And this is the question that I had on this one, that I'm not really sure. It isn't clear to me now, but I don't know a good way to think about, a good way to search this thing. Because it is kind of hard to reduce into a simple keyword to search. The question is, if you have an abstract syntax class, or if you have a class that you're gonna put templates on the class, gonna make the class templated, but you only want some variables of the class to have a certain type. So let's say you have, maybe I should do on SkyDraw. Let's say you have class A. Class B. Class C. If anyone is watching this and knows a good way to search, just comments. So I'm trying to figure out. There's all the ways that I could think about. You can just write a big sentence, and then it becomes very hard to find information. And I think it's just hard to find information about this stuff because it's more related to the context of the thing. Which goes back into the stuff that I said some time ago, is the paradox of search. Because the more specific you want the information to be, the harder it's going to be to find that information because of the nature of incentives. So, like, information that is related to context is going to be harder, and I think that's where AI is closing the gap, and that's going to be the gradient. But so let's imagine you have this class here, which is an abstract syntax class, and then you want to, and you have this B. So you initialize the B class, and then you have another class, which is the B class, which is a templated class. So the problem that's, I think the reason why it was an issue is because a variable of this D class, which is a templated class. I wanted to make the variable depend on the template, but I wanted to structure the class in a way that some variables are going to be from type C, for example, which would be the quadratic Bezier tree curve. And other variables inside of the templated class would be only allowed for the B type. So that's the question that I couldn't figure out. And I think that the issue is because of the instances of the class and how the compiler is gonna solve the templates. But what I was thinking about is maybe you can put some conditions that maybe that's the way you solve this. Like if the template is this type, then and I think ChatGPT gave an answer like this. But the reason why the answer it wasn't the reason why the answer from ChatGPT wasn't good enough is because this variable here depends on the function of the base class. That's the problem. So like there's the variable and the function of the base class. So you can't just check the type of the template here because then you need to call the function on the base class. So how does that work out on the compiler? I'm not really sure how to answer this. But I think it is like one of those fundamental things that is probably good to think about because this is by far, I think, for me at least now, to learn C++, the templates, like this is really the most challenging part, I think, in the context of the situation. And I really don't like types as well. So, but I'm not 100% sure if that's something that is just like by the nature of programming that it has to do that this way. But I think it should probably be possible to have a middle ground, but I'm not really sure. I don't have a lot of clarity because it's going to depend on the compiler. So, like, because the downside of the dynamic languages is that you're going to trade off performance, I think, for making it easier to write code. So, but dealing with the types is very annoying sometimes because you're forced to do a bunch of stuff that is not related to the problem you're trying to solve. It's just to please the compiler. And in some ways that can be a good thing, I think, because like you should think about memory. So, but I think there should be probably a very like a good middle ground. There's going to be a convergence or between these two gradients that is going to depend on the context. And I think the resolution of that is going to be based on the compiler. So that's the kind of the thing that I'm thinking about. So I'll be right back. This is weird. This is something that's I was thinking about as well. Because the way that I'm setting there is based on the example that he gives. And it's just based on this enum here, but this is a hex value. And the values of the color here are RGB floats. So I'm not really sure what is the relationship between this one and the other. Because here is gonna be color here. But this error doesn't make sense to me. Maybe it's because I should do this. Yeah. Not sure what the error means. Fail to compile to any arguments constructor. I think it's because of the vector. It's the way that I'm constructing the vector. So I'm just gonna ask ChatGPT. But this is a problem. Oh no, it's because I'm doing diffuse color here. So I think that's why. So it's obviously not working. Hmm. So I guess I have to put here the error again. This thing here. Oh, it's probably because of this. Because of the way that I'm setting here. Maybe it is working, but it's just one. That's the issue. So the way that I'm setting up there, yeah, so the easiest thing to do is just to change these values. Just see if it's gonna change the color. Because I only did that way because of the example he shares there. But I guess I might have changed this class, I don't remember at all. It's probably better to just leave like this if it works. And then, so the thing that I'm gonna do that I was speaking about before is that, so the way that I'm doing here now, I'm only gonna set once in the first render cycle, then I turn this to false. But I guess I have to do this actually because I think is gonna be very important, obviously, to be able to change the color of the nodes. So I'm gonna have to do the logic that checks to see. And the concern that I have with that is the memory, because obviously there's a bunch of different places and things going on. So I have to see, I have to think about how can I check if the value of the material, the value of the attributes on the variable inside of the material class changes, the value of the color. So I think that the way that they do it is by, on 2JS, is by updating the value of the variable inside of the material class. So there is one value here that is called needs update. And he didn't put on this one. Needs updates. So I don't know why the other one, maybe he forgot. Yeah, set needs updates. Oh, so it's a function, so maybe it has. It needs updates here. So that's how they do it. They keep track of the version, and then the cache that they do should of the program and the buffers also has a version. And then they check to see. They do a loop over all the attributes and uniforms, I think. And then they put some control flow, and yeah, it happens I think on the binding. I know it probably happens on all of them, obviously. But I remember seeing on the binding states class. So I was also trying to think about how do they encode the logic of the vertex colors here, because it should change the way that you set up the buffer. But the only control flow that they have here is for different buffers, and I think that's not how they are not related to the vertex alpha. And it's kind of hard to know what's going on because like the values of the attributes of the program are going to depend on what kind of geometry you're using. So based on the attributes that the geometry sets, is going to loop over all of them here, and then it's going to set up these functions based on the whatever attributes that we have there, based on that function that caches all the locations of all the variables inside of the shader. So it makes it harder to know, because I imagine that's what's happening is that one of these attributes is going to be the, if you set up on the class to use vertex alpha, which is going to be the colors inside of the vertex shader, one of the attributes is going to be this one, and that's how they update the values. It's just changing the structure of the way you update the buffer on this thing here. So you probably you're gonna set the stride. So I guess this is the way you probably choose to figure out, just based on the stride. But the thing that I was talking about now is these attributes here. So they loop over all the attributes and then they increase. I'm not really sure if it's on this one. It's not, it's the needs update, this function here. So they put this control flow that based on these conditions, if there was a change on one of the attributes, this is going to be different. The cached version is going to be different than the current version. Yeah, because it's not going to count the attributes, I think. And for the material, I think it's the same thing. So the question is it better to do, because they're updating, whenever you change one of the values of the material, it updates all of them, I think, based on the way that this works. So the question is if I can do it in one way that only updates the one that changed. So how can I structure the function so that it only updates the one that I changed? And the other question is if it's gonna automatically I guess the question that is most important is when you change the value of the color on the mesh, on the material from the mesh, how does it know? How does the rendering cycle know that the color is different? That's the question that I have to answer. And I think it's through this variable here, because this one is the one that keeps track. But I think that this is going to be true all the time, because each time we run our program is going to be different than the previous one. So this just uses the use program function from OpenGL or from WebGL, and it's gonna so each because this is looping over all the geometries in each one. I guess it depends on the material. So each unique material is gonna have its own program, and you can use the same material, so the object has to be different. So you can have two different mesh basic materials as long as the object is different. It's gonna create two different programs. It only collapse everything into one program if you're using the same object to create the geometries. But if it is different, then it's just going to put this to true, and then it's going to change on one of the conditions here. Maybe it's this one. No, I think based on this, it's going to make the other one true. Yeah, here. So it makes this one true here. So refresh program, then it goes here. But I guess it's just running once. Oh no, this is true regardless, so it's refresh material. So each time there's a new program, so they're just refreshing all the time, I think. Each time the program changes that the mesh is using, they set that variable to true, and then inside of here is gonna update here. So this one's gonna update on the JavaScript values that they cache the specifications of the material, which is gonna be inside of this material uniforms here. This material properties uniforms. And this is gonna be equal to the parameters when they initialize the program here. So they're gonna put a condition there on this function. And this condition here. So it puts the uniforms here. Then it passes this one to this one. And this one is the one that's updates the uniforms, the values of the uniforms based on the values of the parameters, and then here it updates everything on the shader on this one, I think. So I guess it's just updating every time. So I think this can be improved probably, but I'm not really sure. And I'm not really sure if it's worth it. The question is how do they know though? I guess it doesn't matter if you know. So the question is what is happening on the memory? Because I think this is the question that I'm not 100% sure about. What I think is happening is that based on the way that I'm building everything, the material that the program class is gonna have is actually a pointer to the material when I initialize. So I'm just passing the std move function just passes the ownership for another variable. So it's like you're transferring, you're not changing the address of the variable, you're just transferring what variable has owns that value in memory. So I think that's what's happening when you initialize the mesh here. So initialize the material based on a share pointer. So make a share pointer, and then you pass on the initialization of the mesh. And that moves the responsibility for the mesh class. So the mesh is going to hold the pointer to the address in memory that holds the data for the material. And then when you create the when I create the program, it stores this pointer as a value on the program. So now there's two things pointing to the same value. I think that's what's happening. So when I change the value of the material on the mesh, I think it's gonna automatically change on the program as well. So if I update every time, like they are doing in 3JS, then it doesn't matter that much. Because then once I change the value, because what I'm planning to do is the thing that I was doing on SoftViz, which is to put the logic of the colors based on the rendering cycle here. So because I'm gonna change on the mesh itself, because I'm gonna build the graph and then I'm gonna build the stuff that creates the drawing from the meshes. So the point of connection of the data from the graph and the scene is gonna be the meshes. So I'm gonna change the mesh that is related to the graph to change the colors of the graph. But then when I do that, I need to make sure that the program is gonna update it's also gonna update that value inside of the class. And the way that they do it are based on these variables. I think that they update each time. Like the only thing that matters is changing the program. But I think what I can do is just make based on a condition. So the question would be, how can I check? What is the best way to check if the value? Because the downside of doing like they are doing is just is generic. But I guess that's the way it's probably good. Yeah, but actually, I was gonna say that like all we need is a flag variable, because then like you can imagine that I can change the function inside of the mesh or inside of the material, so that each time that I update the value of an attribute inside of the material, it also changes the value of the flag, which is the needs update thing. Then based on that, I do a condition here that checks to see if the thing changed or not. I think a boolean variable, but like I can make it an integer and then swap, just change from 0 to 1, or make an enum. So I can check to see if that value is true or not, and then based on that, I update. But the problem is that if the value is generic, then I don't know which attribute changed. So I think it would be more effective if I knew exactly what variable changed, because then I just set that thing. But the issue with that is that then the function is gonna have to be generic, I think. So I think what this impacts is the design of this function here. So I can use the same function probably to update everything at once on the beginning, and then just update. No, it has to be two different functions, because this one updates everything. The other one would receive the value. So I can make a switch on the other one, and then I receive the value in the base on switch. And maybe instead of making a boolean, I make a. The question is what is the easiest thing to do, because I don't want to think about types too much. So obviously I can make a map and then make the like a boolean value as a key, and the value of the key is the string that's of the uniform that changed, and then I check based on the key, and then I send the value to the function. So I think that's one way, but the thing that I'm not really sure about is an easier way would be to just put the name of the variable that changed. So what I'm thinking about doing is just changing the needs update function. So instead of change the version, just makes the version equal to, or just variable equal to the thing that changed. Variable changed. Or attributes changed. And then I pass this here. So the question would be, because the annoying part about this is then how do I check there if you change it or not? Because I can make two different variables as well, but then it becomes like, and the best way is probably the map, but I'm not really sure if this is worth it to put the map. Or not if I change a bunch of things as well. That's another thing. Like maybe a vector is better. I think that a vector is a good idea. Or a queue. And it's probably... maybe a queue is better, or either queue or a heap. I think I'm gonna do that, because then it allows me to put priority if I want to. So instead of this thing here, so what would be a good name to do this? I think I'm just gonna leave this function and I'm gonna create another one, so in case I regret it, I can just use the other. So the idea that I have is just to check the queue. So I create a queue and then I check to see if it's empty or not. And if it isn't, I just loop over the queue with the attributes that need to, and then I just append or push the thing on the queue with the attribute that changed. So I set the values only once, and then I only set them again if they change the material. I think that's probably better. So I'm gonna ask ChatGPT how to, I think it's standard DQ or something. Maybe I should ask what kinds of data structure. I don't want to say, I don't want to specify too much because then it's gonna be biased at the answer if I put priority. So I'm just gonna ask this then. Or another stats on our map. So this is probably what I'm gonna do. Regardless of the, so this one is gonna be for the first time, and then I'm gonna have another one that depends on the name. So I'm gonna put a switch instead of the thing. But the issue is the types. That's the problem. The types, I wanna avoid as much as possible using templates. Hmm. Yeah, I don't think I can If I do it like this, I can't avoid using templates because I'm thinking about receiving the looping over the queue or whatever I put there, and then over the map, then sending the value to the function, and based on a switch, I call whatever OpenGL or whatever function from the program needs to be called to update. But then from that is I'm gonna go into the same. I'm gonna get into the same issue that's I had on the program itself that I want to avoid, which is having to use STD variant and visiting to resolve the types. I guess I don't need to if I put if else statements. I can do a switch as well, now that I think about it. It's just, I can do based on the string, then I put the name of the string to the name of the variable, and then based on the name of the variable. So I don't need a, that's what I'm gonna do. I'm trying to think about the name. So maybe I should change this one. I don't want to put this one on the singular and this one on the plural because it becomes a little bit confusing, I think. Maybe just I've been here. I do the same thing that I'm doing here. But I think I'm gonna do a switch and then I just put the name of the variable. So I'll be right back. Just remember that what I was figuring out before is just the color thing, so I'm gonna do that first. So I think it works. Yeah. So instead of thinking about how to initialize this, I'm just gonna change the way that. So instead of thinking about how to change the color, so I can pass like this. I'm just gonna change the way that I'm passing. I'm not sure if I can do if I do like this. Hmm. It has to be working to set. It's just the initialization. Oh, so yeah, it does accept here. Oh, with this. If I do like this. So the question is why this one isn't working. Maybe something else. Maybe this one is working. Hmm. It could be because I have to move the color. on the initialization of the material. I'm gonna try that. The thing is, I don't think this is a pointer though. Okay, it's an address. Let's see how he does it. Hmm. Oh, I think I changed this because I changed the way that she was doing the material and the meshes because she was doing a bunch of inheritance or something that I didn't like very much. So these things should do just should tasks like this. Hmm. It's because of the way that I'm putting there, I think. I remember having some problem that was very similar to this. And the time I just did the simplest thing to make it work, so I could focus on the other stuff. So I guess based on the messages here, something to do with the constructors. Ambiguous call to overload the function. I guess if I remove the This is another point of confusion that I had. Like where to put the default value here, if I should put on the definition. Let me try again. Hmm. I need to clarify this thing about the static as well. Because I don't understand why he did the create function with the static. And my guess is obviously because of something to do with memory. Because you want to create only one instance of the class. I think that I don't understand is that they have different. I guess it's just because of this. But this is not the definition though, so. So I guess it is the thing about the default arguments. The question again is how to how can I phrase the question or the keywords to clarify this? But I think this one is easier to think about. So I remember some of the JSON videos. It talks about this template deduction thing. I remember specifically something related to the more specified the function is, the compiler is gonna choose the more specific version possible, and then it's gonna reduce based on that. It's gonna go more generic if you can't find. And there is some stuff about because you can have this is another very big like very confusing part about C++. But I guess it's just a fundamental thing from programming is that you have R values and L values. L values are addresses in memory and R values are data. So you can't dereference an R value because it's just a data, so it doesn't have an address. But you can make a constructor that creates an address for an R value. So it's a like a weird thing, and when you put the 2%, and then when it comes to that, you can have situations where, because that's gonna collapse into an L value on the when it's trying to figure out overloads and things like that. It's very confusing. So it's still not working. So what else can be the problem? It might be because of the create. So, but I think I have to change if I wanna do with the create. I have to change the way that I'm doing. Maybe this way works, actually. I'll try this. Hmm. So the vertex colors are on the material. Hmm. Just gonna do this for now. See if it works. Material value. Hmm. It's true. So what is the easiest way that I can do it here? Let's change this to color. I'm just gonna do this for now. I'm just trying to clarify if the issue that I'm getting there, the reason why it's not changing is because of something to do with memory, or is something else. Because I do think that the shader should be working because when I change the default value of the color, it changes. Yeah, but then it wouldn't make sense to be something related to memory. Yeah, it could be something related to memory actually. But then, question is why though? Let me go back. This is the thing here. If I change here, it's gonna change that. So it is working. It can't be the functions on the render and the program. The question is why isn't it setting the color here? So it should be the initialization here that I'm doing wrong. I do think it is a lot easier if I maybe choose this one. It's a, it's a lot easier to know. I'm gonna try to make it work with the other one. So the thing that I don't understand, it could be something related to memory because I'm initializing this here and then it's passing the address and then it doesn't exist anymore. Because I'm using like the value inside of the class is the same as here. But then the question is why would it work when I with the default value of the color. That's what it doesn't make sense to me. Well, because here I'm just passing the. I think it's something we should do with the translation because I'm not really. I'm not initializing the color. That's the thing. Hmm. Yeah, initial pass. To initialize and then pass. But I'm not really sure if this is gonna work either. I'm gonna ask ChatGPT to see if that's the correct way to initialize. The thing is, with the position, I'm doing the same thing and it works. So I'm just passing. But so I guess I need to think about what is the keyword that is related to this. This position I'm passing like this, but it's a vector 3 there on the definition. And somehow it works. But when it comes to the color, it doesn't understand. Hmm. So the question is, why isn't it working here? Like, why isn't it? Or maybe it is working, it's just the memory when I initialize the other class. The problem is if I initialize, if this is not gonna work. I think it's something. Yeah, it must be something related to the memory, but I'm not really sure why or what. It could be because of object slicing, but I'm not really sure if that makes sense. Maybe it is object slicing, but why would have the variables if that was the case? Because the type inside of the mesh is material, but I'm using mesh basic material to initialize. And I'm declaring the value of the color on the mesh basic material. And this is the problem that I ran into the beginning of today. Oh, I'm declaring here. Oh. Oh, so this is the color that is getting there, that's why. Because I was thinking about moving to this class because it makes more sense. Like the color is the main thing that I'm going to use from the material. So it doesn't make sense to declare here, but the problem is that like if I don't declare here, I can't initialize like this, then I have to change. And I was thinking about how can I do that, and ChatGPT recommends to use the constructor of the other class to initialize. So you pass like this, but then the problem is I wanted to pass the base class and then you initialize. This is gonna call the constructor of this one, but the problem is that I wanted to, because this one requires to initialize with this thing here. So when it puts an initializer list and you put more than one variable, it doesn't work for some reason. And I was trying to think about a different way to do it. I guess I'm gonna try. The problem is if I comment here, it's not gonna work, I think. Yeah, but I think that is not an issue. So I'm gonna test, but probably the reason why is going with the base is because of the type on the mesh. So because the class is declared as a material on the mesh, it goes to the variable from the mesh first. But maybe not. Because it is declared on both. Let's see if I don't declare here, yeah. So it doesn't work. Usually only works the other way around. That's the thing. It's like if it doesn't find on the derived class, then it goes to the base class. So What can I do? And the question is, what is the easiest way to solve this? Maybe I can just put a function for now, and then I think about this later. So I initialize a caller inside of the function here. This is the thing also. I think I tried this, and then if I do this caller, not really sure if it's gonna work. Or maybe this way works. Nice, finally. Uh, the hardest part is to think about the other stuff. So that's the thing. I'm not really sure what, because the hardest thing is just thinking about the overall thing and how everything comes together, and not necessarily these nuances here. But I think I'm gonna leave it like this for now, because the other way is just gonna be annoying to figure out how to do the initialized list. But maybe the thing is, and I don't know if like it's just me or it's probably just hard. 'Cause, like a lot of these issues that I'm encountering would be good to study, to understand better how it works on the fundamental level. But it's really hard to come up with like good ways to search. That's what I'm struggling with. Because usually it's more like about the context of these things. But maybe I can just put your initializer list or something like that. And that's the thing, because then it involves abstract classes and inheritance. Yeah, maybe this. So honestly, I think I'm just gonna leave it like this for now. I think it's more important to think about this than to think about the optimization than adding other stuff for the materials, because I don't think I'm gonna need anything else. If I need other stuff, like once it gets to the point of getting the data, it's probably gonna be related to textures and not so much on the specialization of the material. I think specialization of material is more important if you want to build a game or something like that, because then it matters more, like the lighting and all that stuff. But for what I'm trying to do, it's probably not very important. It's probably so probably I should leave like this very basic, and then I should just focus more on trying to incorporate this on the programs class. And also this other stuff here is gonna be annoying as well, like labels and anti-aliasing. And camera controls I can get from the other probably. So I think I'm just gonna leave like this now. And I'm gonna move on to these other things here. And if I need later on, I do something else. Well, the thing that I have to test still is whether what happens if I change the color. That's the thing. So I'm gonna do this now. This is the last thing that I'm gonna do. Then I'm gonna stop streaming and I'm gonna focus on the other stuff. Probably just gonna watch videos and about this other stuff here. And then tomorrow I just focus on these other steps. Then once I finish this, I think about whether or not it's worth it. I think this step here, I'm gonna think about whether or not it's worth it. Should do it. It's probably worth it. So I'm gonna have to change the shape. Yeah, but maybe it's not worth it because I'm gonna have to spend a bunch of time understanding how 3GS sets up the attributes with the strides. But maybe it's not that hard, honestly. I think it's actually not that hard. So it might be hard though because you have to understand the functions to the way that they set up the points to create the geometry and how that's gonna be related with the how they set up the final array that they send with the data. Just send the colors as well. So I'll be right back. It's gonna be annoying if I want to incorporate the same way that they did because I'm gonna have to figure out how they at what point exactly. And it goes back to the thing that I was saying that of the attributes here because you set everything up. But now that I've seen there, like maybe I was looking the wrong way because they do set the vertex on the material and not the geometry. The they do set the vertex thing on the material. The vertex colors. I'm not really sure if this is related to the. Yeah, it's a different name. It's vertex alphas, I think. So what I have to spend time understanding if I want to do that is how do they set up this function here to set up the attributes. And I don't think there is anything. There isn't anything on this function that, at least as far as I looked, that indicates what's gonna happen when the geometry has the vertex alphas. Because the thing that is gonna be different is that is the data that you're sending to the buffer and the strides. So you're gonna have to call this function twice if you set the colors, and the other time is gonna be the location of the varying color that you're gonna use to color the vertex point that you're gonna send to the fragment from the vertex. The first time is gonna be the value of the position that you're sending. Then the other one, like you're gonna have to merge the two different standard lists that he uses here to create the geometry on each class. So these values here. So I have the vertices, which are the points of the position, and I'm gonna have to change this array so that each time after each point, I append the value of the color of the thing. So this is the problem, because like I don't think it would be good to change on the geometry class itself, because that's probably not how they do it, since it's not set up in this way here. So I guess that the only thing that makes sense is that at some point when they're setting up the buffers, as they are getting these attributes here, maybe they set, maybe this would be the easiest way. You just set up another buffer. Yeah, I think that's probably the easiest way. So I guess I can do something like that. But now that I realize, yeah, now I'm not. I think it's not gonna be worth it, to be honest. Like, it's too much work, and the benefits not gonna be that good, because what I would actually have to do if I want to optimize this is to make it dependent on the fluctuation of the data. So, like, depending on how equal the spheres are gonna be to each other, then I do the batching, because I just realized that they would have to have the same radius because the points are the same. So that's the only way I would be able to color all of them separately and still render them all simultaneously. They have to have the same radius. Maybe for the edges, but then that's the thing, because either way I'm gonna have to put some logic that determines what kind of nodes and edges are not gonna change during the or are the same during the visualization. And I might structure things in a way that the visualization changes in real time. So that's the thing. Because if it is static, then it probably is not that hard, because then you just loop over the graph. Or as you create the graph, you keep track of which nodes have the same radius. But I think it's just too much complexity to add to be worth it, the performance. Like, it's probably a lot better to optimize a bunch of other things first. It's like a micro optimization thing, I think, here. So the way that I'm thinking about doing is just, if I do this, maybe I can do it and then like just put the initial steps, and then later on, if I want to, then I finish. So the easiest way that I can think about is just create another buffer. So as you create the VAO, you put an option that if the if the program is gonna require batch rendering, then you put another option inside of the function that creates the buffers, the VAO and the attributes, and then you just create an additional buffer with the other attributes. But I guess it's already doing that automatically, now that I think about it, because I'm looping over all the attributes. But now it's just doing with the position, because the position is the only thing that I'm using inside of the shader. So this fetch attributes gets the locations of the variables that are active, so the ones that are actually being used inside of the shader. So even if you declare something else, it's not gonna get these variables. So if I put another variable here that the shader is not using, it's not gonna return there. So it's not gonna loop over them, because I'm not gonna cache them. So I think if I put the variant in there, it's probably gonna, and I use on the fragment, it's gonna get this, and is already gonna loop over, because I'm going over all of the attributes and creating and updating them right here. So it creates a buffer already for all the attributes. So the question that I will have to answer is how, because I assume that probably they makes based on just a flag variable there then. Because I think that, yeah, maybe the difference is that the color has 4 is a vector of 4, and the, yeah, color is a vector of 4 and the positions are a vector of 3. So I think the only thing that changes is probably this, like the type of the you specify here. But the thing is that this comes from the geometry, which comes from these values here, and in none of the geometries I've seen the set attribute for the, maybe it's this UV here, but I haven't seen the vertex alpha thing. So it should be on the material that it is specified. And maybe it is worth it spending the time. So I can spend a bunch of time looking at the rendering cycle, trying to figure out where exactly is gonna change the way that is initializing the buffers based on the whether or not the vertex has colors. Yeah, but I think it's probably not worth it because it's just gonna be too much. Because I have to think about the other stuff of what nodes are equal and what nodes are not gonna be equal. And then I have to create control flow logic on the programs to decide what kind of shader and programs are going to be used based on that. Because then obviously I would decrease the size of shaders as well that I use. Because all the nodes that are the same would use the same program. I think it's not worth it to do it. So I'm not gonna do it, but I'll keep in mind. So the last thing that I'm gonna do today is just try to change the value of the color. I have to see how to do that. See if on the example he does it. I think you just make it equal. I'm just gonna make it equal. So it's probably sphere material. I know how do I compare this? I guess just graphics. Yeah, because it's gonna be RGB. I don't want to think about it too much, so I'm just gonna do it like this. I want to see if I change the value of the color on the material of the sphere is going to change the one on the shader. I have to, let's see here. Let's do this. No, I don't know. I don't know if it's changing or not. I think it has to be. The question is how to make this is lower, so I can see. So. But it has to be working, I think. Because otherwise it would just be the other color. I think it's just switching very fast, so yeah. I could just do a while loop inside, yeah. I know what I put last time. It's just crashing the thing. I don't understand why it's not going back to the other color. It's probably related to the same problem that I had before. The reason why it wasn't setting the color in the first place. So if it is, it's gonna turn this. It should be flipping back and forth now between black and white. I guess another thing to do is just print there. Actually, I don't know. It's probably because of the order of the rendering. I think is working. It's just like it's because I don't wanna think no to do this stuff here. So I'm just gonna stop streaming and I'm gonna watch the videos and then maybe I'll think about today the other steps here. I'm probably gonna have to spend a bunch of time watching a bunch of videos and reading things for the labels. So probably won't stream for some days. I'll just figure this out off stream. But I'm gonna continue to do this next time, obviously.